I'm Jassi.
I'm Kavin,
I'm Sam.
and this is a lab vibe picture and strain measurement presentation report. So this experiment uses a Wheatstone bridge circuit measured by electrical resistance strain gauges to measure the strain-related voltages to find the actual strain to plot stress and strain. Then a three-point bend test is performed to identify the displacement using a controlled load. Then the data collected will be used to find the Young's modulus, which is found through the plotted linear region of stress strain. And the procedure for this experiment is a strain gauge was bonded onto the surface to track the changing voltage. Then the sample was bent on a curved surface and the output was recorded. Then the sample was loaded onto the three-point bend fixture and the load was applied and the max load was 8 pounds. The displacement voltage and the load was all tracked and then analyzed.
So the first graph we produced for this was a load displacement graph. So when we ran our sample through the bending test on the actual fixture, we ran it up to about 8 pounds of force, and we plotted the displacement coming from that as well, the linear displacement from the strain gauge. And from that, we were able to discern a stress from the graph, which is about 4.12 psi. And that would be used combined with the stress found from the initial part of the lab where we had to calibrate our strain gauge and figure out how that worked to find a Young's modulus. Our second graph produced was a stress strain graph, also from the data from our actual bending test. So using the formulas provided in the lab manual, we were able to find the stress and the strain, and we found an elastic modulus of about 474 kilo psi. And then we also produced a graph of the length over deflection. So pretty much modeling what we saw from the actual experiment itself. The maximum deflection was in fact at the middle of the beam. And there was a parabolic relationship between the deflection in the beam and the length of the beam. And then for results and analysis, we found the elastic moduli and the percent error. So for the error found from our load displacement graph, we got about 582 kilo psi with a 43% error. And for the Young's modulus found from our strain gauge, which is our second graph, we got about 474 kilo psi with a 17% error when compared to our reference value.
So there are some key takeaways from this experiment. Neither Young's modulus displacement and Young's modulus strain gauge provided a high accuracy, but the Young's modulus strain gauge was much closer to the reference value, which means that both means of measuring had systematic errors. A key finding was determined through the divergent values of Young's modulus strain, which was that the beam was much stiffer than expected since displacement was much lower than expected, which is what gave the high error. This high error can be attributed to a mistake in the setup or incorrectly interpreting the values that we measured. The error observed in Young's modulus strain gauge can be attributed to an angular misalignment in the gauge setup.
So the main takeaways from the lab are that the percent error for the load displacement, as stated before, was 43, which was rather high and a lot higher than what we wanted. But for the Young's modulus of the stress strain graph, it was a lot lower at 17. It's still a little bit off, but since that was low, like decently low, it can be attributed to matching the theoretical values somewhat. And then from that, you can also say that the data gathering method was actually sufficient enough in proving the theoretical to be true. For future work and recommendations, we can learn how to properly set up the strain gauge. Our group struggled with doing that, and we actually had to be given a pre-made one, unfortunately. So in the future, we can become more proficient with that so that we don't take as long. And then we can also be more careful in handling the part so that any error from damage to the actual gauge is negated completely. These are our references that we used, and that is all.
Thank you very much.
Thank you.